Hello everyone, my name is Ramat Mahajan. I'm going to use a simple example from Java to talk about race conditions and how you can use language specification like synchronize to avoid these race conditions basically. I'm going to use an example of these simple classes. Point represents XY coordinate on a Cartesian plane. Rectangle has a bunch of stuff. X and Y represents the origin, length and width, the corners of the rectangle, and then a method to generate these corners. If the corners are null, it'll generate these corners and print them out. If they're already generated, it'll just simply print them out. Very simple. Let's see how it executes. So, simple example, thread 1 comes in, creates a temporary array, calculates these corners, and then assigns them to the corners class variable. Very simple execution. Now let's put a twist in there. Java or JVM can reorder statements. So in this case, corners equal to temp has moved from here to up here. This is typically done if the writes are being clubbed together as an optimization to execute things faster and other various stuff. It happens at the lower level. But yes, the point is this can happen. So the order of execution is not guaranteed to be the order of statements you've written. So let's see what happens in this case. With the same example, you see a temporary array being created. The array now is assigned to corners before all the corners are calculated. So that's the difference. However, the execution remains fine because after all this, now is when we print these corners out. So Java has reordered these statements, but it has done so in a manner that maintains the correctness of the single-threaded execution. In fact, that's what Java memory model does or specifies. The optimizations can happen, this reordering can happen as long as single-threaded execution remains correct. But now let's look at what happens with multi-threaded execution with this reordered code. So you have a thread 1 that comes in, creates the temporary array, it's assigned to the corners class variable. Now then thread 2 comes in, it sees that this is no longer null. It points to an array, so it goes out. Note that the array does not have calculated corners. It has null garbage values. So corners of any index is going to be null, and this right here will give you a null pointer exception. So thread 2 fails. Now thread 1 can go on and can generate all these corners, and now it can finish execution perfectly fine. If thread 2, a point to note, if thread 2 had actually come in after thread 1 had generated these corners, it would have executed fine as well. So this is the race condition, right? Things can go right or they can go wrong. This is usually a bad idea for production. So you need to maintain correctness and some deterministic behavior there. And so you need some degree of, you need to use some level of language specification to kind of coordinate these threads in this example. One way to do that is to use the synchronize method. The synchronize method basically restricts the execution of a block to a single entity. So if another entity wants to execute the same block or method of code, it has to wait until the first one is done executing. So thread 1 comes into the synchronize method, creates a temporary array, assigns it to corners. Now thread 2 comes in. It's blocked because it's a synchronized method. Thread 1 has to finish execution. Thread 1 generates these corners, and then it's going to print them out, and then it's going to be done. Now thread 2 is allowed to execute this program. It does so. It observes that the corners is no longer null. It goes to print them out. And observe, this time, the values are actually filled because thread 1 was allowed to execute the method fully. Therefore, thread 2 can simply rely on this pre-computation. And it's able to print this out successfully. And in this case, both threads execute perfectly fine. That's a win. So two things you should remember. Order of execution is not guaranteed to be the order of statements. It can happen or it cannot. Synchronize restricts the execution of the method or the block of code to one entity. It helps you with coordination. And so you can use this to avoid these race conditions. There are other ways to do it too, but I'll restrict this session to just the synchronized language feature. I hope this helps. Thank you.